Okay, so in this video, we're going to work on the very first steps of our new project. And in this project, we are going to make the Vise Stop, which is also over here, and the Edge Finder, two different projects. So on the mill work, it'll be the Vise Stop, and on the lathe work, it'll be the Edge Finder. So this is our parts list, bill of material. So we're going to switch and flip over to talk about the moving and the stationary jaw on the Vise Stop. So typically the first thing we want to do is get our material to size. So that would be thickness, width, and length. So we have a 0.5 and a 0.5 thickness and width. And if we look at our tolerance block down there for 1 decimal point to one place to the right of the decimal, we have plus or minus 15 thousandths. We are using stock size, 1/2 inch by 1/2 inch, which falls within that. So other than, deburring it and making it pretty, we don't have to change that thickness or width. So that means we need to worry about the length, which is the 1.5 dimension. Down here is the overall length. 1.500, which is plus or minus 5 thousandths. And the stationary jaw is also the same, 1.500. So we're going to make both our parts to length at the same time because it'll save some work. So I need you to take a look, because when we get this material, it's in a long bar, and we cut off all these little pieces. And when we cut them, it leaves a sharp edge. And the best way to show this to you is I'm going to zoom in here for you. Hopefully. Yeah, there we go. Okay. So you should be able to see that on the back side here, there's this big burr. Let's see if I can come a little closer. So see, look at that thing. That's huge. Okay. Aside from it being sharp like a razor, like a blade, a knife to cut you, all of these other edges, even though they look a little bit smaller, they're still basically a smaller version of this. Now, let's say I'm very careful and I don't have to worry about getting cut because I'm careful. It still is a problem because we're going to have to put this part in our vise here to machine it. And so this is an exaggerated version, but look at how far that end is raised up. It's on an angle. Now, if we have a plus or minus 5 thousandths tolerance or a closer tolerance, even a little teeny tiny burr, which I really can't see much here, could be 3, 4, 5 thousandths, knock me out of tolerance. So there's a process called deburring that we will use. And we'll get a file. Okay, and so the way that I file and teach is I do 45 degrees. And you push on a file, flip it, push, 45-degree angle. If it's 30, 27, that's not a big deal. Then I highly recommend that, well, after you do the other side. Now, some people have a little trouble with holding it because it's small. So I could put it in my vise here, tighten it down, and I could actually do it this way. And then I don't have to worry about filing my fingers and achieve the same thing. Of course, that really big burr is going to take a lot more work. So now that I have the 45 on all 4 sides, you can see a nice little, they call it a chamfer. That edge is broke. You can see where it's shiny. But sometimes when you file, it pushes a burr across the other way, kind of like what we have now in a different direction. So I recommend after you do the 45, you lay and go flat and just rub across flat. And if there's any little high spots, you've just taken them all off. Same thing on the end. lay it flat. So now this thing is ready to go. So we need to do that with the other one. I've done it this way, done it a lot, so I'm used to it this way. And every now and again I do file my fingers. And yeah, I'm not really fond of it, but you know, it happens sometimes. So here we go. So now this is ready to go. So process-wise, with my two parts, what I'm going to do is I'm going to use an end mill. This is a double-end mill. Center cut. My flutes go all the way to the center, so I could plunge a hole with this. Got us a nice one. Okay, it's got flutes on both ends, so it's double end. And there's 1, 2, 3, 4 flutes. Okay, so it's a 4-flute double end, so it's good for steel. And I'm going to have to put it in that collet. Find the right size collet. This is a 1/2 inch. Remember that when we calculate our RPM, 1/2 inch. So this will go in the collet. And remember, you don't jam, well, I don't know if I told you this, but you don't jam it all the way up, because inside the collet, this diameter only goes so far. And if I jam it up in there, it's going to do some damage to these teeth, okay, the flutes on the corners. So you also don't want it so far down that you're actually clamping, because remember, this is a taper and it squeezes it. Clamping, you don't want it clamping on the flutes because it'll damage them that way also. So you want it hanging out and clamping on actually the straight part, the shank. Okay? So, actually and honestly, I need to take my watch off so that it is not a safety hazard. And then I am going to also take my ring off. So I have no jewelry of any kind on my hands. My sleeves are pushed up, which you should be able to see while I'm doing this. So no jewelry, no watch, sleeves pushed up, so that I can start working on this. So with this end mill, since my thickness and my width are done, I only have to do the length. So what's going to happen is I'm going to hang my part out the vise a little bit, and then I'm actually going to take my cutter and I'm going to go across the end and then come back. Now I briefly talked to you about climb and conventional. So the cutter's spinning this way, and it's going to conventional mill, so it chops in the front. I can make a 0 pass where I don't change my movement, and I can come right back and it'll smooth it out. But anytime I move in, I want to come, if I'm working on the left-hand side, which we usually work on the left-hand side, you go from the back to the front. And the reason I like the left-hand side is because then when I move my cutter out here, it's safer. Whereas if I go the other way on the right-hand side, in order to get off the part and cut conventional, my cutter's up here in front. Then I have to reach past my cutter in order to touch my part, which is a bad plan. So now I can't just put this way down here, okay, because it's too far down and it's way easier to do some damage down here. So we have these things called parallels. And let me zoom this back out a little bit. Parallels. We have some nice parallels in a box. So they're all different sizes, from little to big. The reason is I want to be able to get my part sticking up. Let's come back into the zoom. I want my part sticking up a little bit above so that my cutter doesn't run into these jaws on the vise. They're hard, it'll destroy the cutter. But I don't want it so far raw that when I tighten it up, my part pops out when I start cutting it. So I want to be somewhere in the middle. So it's a little bit of a guessing game. I put the parallels there. Oh, I guess, let's see, can I go a little deeper? No, that's the wrong way. There we go. There's my parallel. My part's sitting down. Now I don't want my parallel sticking out because my cutter is going to be coming along here and I'll hit them. So the way that this works, actually and honestly, they call them parallels because they're precision ground parallel. They're both exactly the same height. So you want to make sure they're clean. You want to make sure that inside the vise is perfectly clean. Because as I said with the burr from the saw cut, if that's enough to cause your part to get crooked, so is a chip in the bottom of the vise. Clean these. If you happen to drop one of these parallels, you need to let me know because we need to inspect it because there's a chance it most likely made a dent, and that dent is no different than this big huge burr that's on the end. It will make it not parallel. So we just have to fix it. So I'm going to put this in, slide this in. I want this inside the end of the jaw a little bit. Put this one on the back side. Close this up some so that my part actually sits on the parallels. So the parallels got to be inside so I don't cut them. Now sometimes the parallels move on you, and what I've found is if I get this handle, are we all the way out? No, we're not. If I get this handle to where it's like, now it's tight on the part, I take this handle and I put it here at like 2 o'clock-ish or something like that. So that, I'll turn it to here and then I can use the weight. So watch this. I'm going to open it, my part is loose. I can put this by me. I can adjust my parallels. I mean, you can always get another person to help, but sometimes they're not available. You always want to hold your part down, and then I'm going to move away. That swings down. Now my vise got tighter, and so now I can tighten it up a little bit. Now, sometimes it's not perfectly flat, so you kind of need to seat it, shall we say. So I'm going to move my X over and my Y out so that I have some room. And then we have this special, it's called a dead blow. It's got shot in it, listen. So it deadens the blow, okay? And so we just tap on it. Now if I tap way on the end, I can make it crooked. I'm not trying to kill it and beat it to death. I'm just trying to tap it a couple times to help seat it down. That's it. We're good. Okay? So my part's ready. I don't need any more parallels. I found the right ones. Put them over on the bench so that they don't fall. They're expensive and delicate, accurate. So I got to move my table in. I'm short, so I need to stand on a stool in order to put our tool in. By now you should have watched the video on how to put a tool in the spindle. I am going to make an adjustment here so you can see me put the tool in the spindle. So I have already got my collet from my rack over there. Remember, there's a groove in the side of my collet. There's a pin in the spindle. So I'm going to find my, there, it's over there. Remember, they got the drawbar up top here. So I'm going to rotate it carefully. There we go. I'm going to get it started a couple times. Boom. See, now it won't fall out. Now I can go and get my cutter. I'm going to push my cutter up in there. Now if you turn that a lot and squish it down a lot, it's going to be collapsed and you're not going to be able to put the cutter in. Never want to tighten that. Keep tightening, keep tightening, keep tightening, and collapse the collet, because if it collapses beyond the range of the collet it's supposed to clamp, it will crack the collet and break it. So I'm going to push it up, pull it back down so I know I'm on there. So basically I'm holding my fingers on the shank, not the flutes. I don't want to get cut. Push it up, makes it easier to tighten. Tighten it, hand tight. So now, notice I'm off the vise so that I have a bench here so that if by chance it falls, it's going to go here. Now, as we're learning this, I recommend getting someone else to hold this and hold the brake. Remember, you got to hold the brake in order to tighten this. See if someone is holding this on the shank and this, when you tighten it, it's okay. And it won't fall out. So, I put the wrench up there. To tighten, I'm pulling it towards me. I like to do things a little bit easier, so once I get it tightish, I can let off and rotate it back, grab the brake again, pull towards me again. Well, I don't have to wrench the tar out of it, just good and snug. All right, make sure you take the wrench off, never leave the wrench on. If someone turns the spindle on, this thing flies, makes a lot of noise, breaks stuff. All right. So that's tight. So that's done. So now it's time to do our math calculations. We're going to use 100 surface feet per minute. We are going to, I want to get this set so that when we need to go in, we can. I'm going to move us over a little bit, because when I start cutting, you're going to want to be able to see more down the side. That should work. Now let me move out. All right. So, we talked about the quill in a previous video. The quill comes down. I do not really want this thing. Oh, see, now someone's got this so loose it won't lock. Don't let go. This thing flies around and hits you. It hurts. I'm telling you, I've hit my hand right on that bone. It hurts. Okay? More than once, unfortunately. So I hold the black disc behind it. I pull out and rotate this. Let go, push back in. Now I'm tight. Okay, good. Do not just move this down a little bit and lock it, because what happens is when you say, oh, I need to go look at something, you lift it up, you will not come back to the same spot. So that's why we use the quill stop. So there's two discs here actually. So if they're kind of loose, you can spin them both together. Or you can spin one at a time, two hands. I like them about halfway, because that way I get some extension with the quill and I go the rest of the way with the knee. Snug them up against each other like a jam nut. Lock it. So now I'm not close enough. I move over, I'm not close enough. So, how am I going to get there? I hope you're saying we're going to lift it with the knee. So I'm going to come on this side, knees down here, handle in the front. I'm going to raise it up. Now, let me show you something here. So I raised it up. But, let me get closer. Notice I don't have the spindle on yet. What we need to look at is the bottom of the end mill does a lot of cutting. In this case, we're going to use the side of the end mill. So, the end of the end mill gets used a lot when I'm cutting across the top of something. The end gets dull, but the side doesn't get used a lot. So when we're using the side of the end mill, go down farther to get away from the dull part so you have a nice clean sharp. Now the flutes stop before it gets to the top. It stops about here. Okay, the rest is clearance. So you don't want to go too far down. So I'm going to move over and look at it from the front here. And so I'm lowered. Got to get out of the habit of that. So I am below the bottom of my part. Okay? Double check. Okay. So I'm not touching the part. I'm close to it. I'm not going to tell you what RPM I ran this at because I'm going to make you do the math. I did the math. I already said it. Quick reminder. What gear am I in? High or low? I'm looking on the side. I'm in high gear. I want to be in high gear. I want to set my RPM up here, which I already did. The spindle is off. To change this, the spindle is on when you set it. So here's the process. We're going to turn the spindle on. We need to be, if this is my cutter, we need to be somewhere in the middle of it, front to back, and then we're going to actually move over with it running until we just barely touch, and then we'll move back. Okay? So we're doing that because it's not all the same diameter. Where the flute is cut away, if I come in and touch without it spinning that way, it's going to give me a false reading. If I don't get into the center of it and I'm only part way on it, we know that a circle at the straight across perpendicular is as big as diameter. If I only went on part way and I'm up here somewhere, then when I come on the rest of the way, all the rest of this is going to get cut. So that's a no. That's a no. So